Alright guys, this is Mr. Gibson. I'll show you guys how to calculate limits to infinity. So basic idea here is that when we have a limit approaching infinity or negative infinity of some function 1 over x to the n, it's going to equal 0. And I'm going to show you guys this graphically. So if I look at this graph, this is a graph of 1 over x, and so as x goes towards infinity, it just gets closer and closer, but never touches 0, because again, 1 over 0 is undefined. Same thing this way, towards negative infinity. But it will all get closer and closer and closer to 0. And we can actually see this with the table as well. 0, of course, is an error, okay? But if I change this interval to something really small, maybe even make it smaller, oops. Okay, good. You can see, oh, I want to do the opposite. Let's do a big interval, so we can see as what happens as it gets closer and closer to infinity. So these big numbers just get really, really, really small because they're getting closer and closer and closer to 0. You can also see this if we write this out. So I mean, if I have 1 over 1, then it's 1 over 2, 1 over 3, 1 over 4, 1 over 5. It just gets smaller and smaller and smaller, the number. So as the denominator gets bigger, the number itself gets smaller and approaches 0. Okay? So we keep this basic idea in mind because it's going to help us to evaluate limits like this. So the first thing I want to show you guys is sometimes when you have two functions combined into one function, it's best just to separate out the limit like this, because this is allowed. So I can take the limit as it approaches infinity of 7 and plus the limit as it approaches infinity of 2x squared over x squared. X plus 2, or no, x plus 3 squared, sorry. No. Alright. This is helpful because the limit of any just number is just this number, is the number itself. So the limit of this is 7. Alright. Limit of this, we're going to have to do a strange technique. So first of all, I actually want to multiply this out. So when I multiply this out, I get x squared plus 6x plus 9. Alright. And I want to look for the highest order in the denominator. Highest order in denominator. Alright, in this case it's x squared. Okay? And so I'm going to multiply everything by 1 over x squared, 1 over x squared. So essentially I'm multiplying by 1. But we'll see why we want to do this in a second. So 7 plus limit as x approaches infinity of 2x squared times 1 over x squared is just over x squared. Multiply everything down here by 1 over x squared, so I get x squared over x squared plus 6x over x squared plus 9 over x squared. Okay, simplify this just a little bit more, and I get limit as x approaches infinity of 2, because those x's cancel, over these x's cancel and make 1 plus 6 over x plus 9 over x squared. Well, as we've already talked about, as x approaches infinity, as the x in these denominators get bigger and bigger and bigger and bigger, the number gets smaller and smaller and smaller and actually approaches 0. So these two values will be 0 as x approaches infinity. So I'm going to end up with 2 over 1 plus 0 plus 0, my 7 right here, which is just 2 over 1, so 7 plus 2 equals 9. So the limit as approaches infinity of this whole thing equals 9. Okay, so that's an example where you'll kind of hit a lot of highlights of a lot of different methods you're going to have to use. But that's the basic idea of what you're going to have to do for each one of these as they approach.
Teaching students, let me have your attention.